Hi everybody, this video is picking up where we left off in class. We had just started talking about convergence testing. So again, in your notes you should have titled Convergence Testing Intro. And we had started talking about these two series right here. Now keep in mind that you're going to be learning a lot of different tests to see if a given series, like these are all examples of series right here, to see if a series will converge or if it will diverge. And remember, we care about series converging or not because we can only use a Taylor polynomial to approximate a function if that Taylor polynomial converges, if the terms add up to a finite specific value, or if all the terms go to zero, if the infinity term and the Buzz Lightyear term go to zero. And we had talked about these two in class, and we had said, all right, whenever we go whole hog here and we actually use this in purple here. Now, I don't know if I use this phrase in class. I'm going to use what I highlighted here, and I'm going to call it the generator. The generator is what's used to actually get all these terms that you're adding up. So when I refer to the generator, that's what I mean here. And we had said that because each of these have terms that do eventually get to zero, we had said that these could converge. We're not sure if they do yet. We haven't gotten there yet. I will eventually reveal the big mystery to you here. And we had pointed out in class that this one converges faster than the one above it because it has way fewer terms. This one, oh, that's a third. This one has more filler terms here in between the terms that 1/2 to the n has. Now, I want to point out something here because this is an important manipulation that you're going to have to be comfortable with. If I have a fraction with a 1 in the numerator, and if I am raising it to a power, so if I have 1/2 to the n, for example, 1/2 to the n is the same as 1 to the n over 2 to the n. And 1 to any power is just going to be 1. So just realize if you have a fraction with a 1 raised to a power, it's really just 1 over the denominator to that power. That's something that you're going to need to be comfortable doing because whenever you manipulate these, that is used fairly often. So what we had said again is in order to converge, we need to get to zero eventually as we go to infinity. But here's the key. The series is going to need to go to zero fast enough. So this one goes to zero faster than this one, but we still haven't decided if they get to zero fast enough. So here was the nth term test. This is the first test that you learn in class today. And nth term test said that if you have a series, and when you do the generator and you get your terms, if the terms do not go to zero eventually, the series 100% diverges. That doesn't mean it converges. All it means is it's a candidate for converging. We're not sure if it converges for sure yet. So these are candidates for convergence, each of these, but we haven't done enough work to see if they actually do converge. Again, this is not a test for convergence. It's the first thing you're going to do to see if it even possibly could converge. Before we go any further, I just want to make sure you write this down here. A couple weeks ago, we talked about geometric series, and geometric series had a common ratio, and we said that the geometric series is going to converge if the common ratio is less than 1. So this is actually the very first test that you knew or that you learned without really knowing that it was one of the tests. It's the geometric series test here. So again, if you have a series and your generator is in the form ratio r to the n and this number is less than 1, it's going to converge. So this converges if the ratio is less than 1. So please make sure you have that written down because you will be using that one. Here's the nth term test. Now, I had given you these 4 series, and I said, all right, go whole hog on these, investigate, see what's going on, see if they are candidates for convergence. Do the nth term test on them. So could they maybe converge, or do they definitely diverge? So whenever you take your generator here and you plug in terms, you should have gotten this. You might not have gotten all the way as far as I did, but hopefully you get the idea here. Now look at these terms here, and you want to see, do they seem to be doing anything? I'm going from 2/5 to 6/7 to 1 to something bigger than 1. These terms don't seem to be going to zero. Let's see if they're going to something else. Let's actually do the nth term test. The limit as n goes to infinity of my generator. Well, here's my generator. So you need to be able to take your generator and let's think here, how do I do a limit? And because my degrees are the same, you can think of the horizontal asymptote here. A limit as n goes to infinity is a horizontal asymptote, so 2 over 1. The limit's actually 2. So if you go far out enough, if you actually were to go to your infinity term is 2. The Buzz Lightyear term is 2. And then if you kept going, you would be adding a bunch of 2's here. And if you keep adding 2's, you're never going to get to one finite number. So that means that this series 100% diverges. So again, this is what happens eventually whenever we go to infinity. All right, let's take a look at the next one here. So I had 3 halves to the n, and I have 1.5, and then I have 9 over 4, 27 over 8. I'm not sure if these are actually getting smaller and smaller. So they don't seem to be getting smaller, and they don't seem to be going to 0. Let's apply our nth term test and see what's happening eventually. So I'm going to do the limit as n goes to infinity of my generator, 3 over 2 to the n. Now, I want you to picture taking 3 over 2 and raising it to the infinity power. Now, 3 over 2 is 1.5. Raising a number that's bigger than 1 to a power makes it bigger. So like 1.5 squared is going to be bigger than what 1.5 was. And then if you cube it, it's going to get even bigger. If you had taken a number less than 1 and raised it to a power, the number would get smaller and smaller. But anyway, if you keep raising this to bigger and bigger powers, you're going to go to infinity. So that means in this case, your infinity term and Buzz Lightyear term will be infinity, unlike the one above it. The one above it got to a finite number, but the problem is if you add all these up, they will not be a finite number because the sum keeps getting bigger and bigger. The sum only levels off if the individual terms are nothing. So because it fails the nth term test, so our series is definitely going to diverge. What that means is that these two are not even a candidate for convergence. There is 100% no way they're going to converge, so I'm not even going to do anything else with them. Let's take a look at this one here. So here's my generator, a sub n. I start with 6, and then I eventually get to a number less than 1. It could be possible that if I keep going to my infinity term, that it goes to 0. But just to be sure, let's see what happens eventually. And let's do the nth term test. So the limit as n goes to infinity of my generator minus 2. Okay, so here I'm going to do my horizontal asymptote test again. The degrees are the same. So the limit as we go to infinity will be the ratio of the leading coefficients. A third. Shoot, it's small, but it is not 0. So this series, even though the terms seem to be getting smaller, this definitely diverges because you're going to end up adding a bunch of 1/3. So if you go out far enough, you'll just keep adding a third. So adding up a ton of numbers that are not zeros at the end, it's going to keep getting bigger. So this diverges. It fails also, so there's no way it could converge. All right, let's see if we have at least one that could possibly converge. So let's take a look at this one. 5, 5/8, 5 over 27ths. All right, this is looking promising. Let's see what would happen if I kept going. These are definitely getting smaller. The question is it good enough? Do the terms actually go to 0? So the limit as n goes to infinity of 5 over n to the third. Okay, so if I plug in infinity here and then cube infinity, this is definitely going to be 0. Another way you could think of it is the horizontal asymptote. If the degree, this is really n to the 0. If the degree is bigger on the bottom, the horizontal asymptote is always going to be 0. Or you could just think if I have 5 divided by infinity, it's going to be 0. So that means my infinity term is 0. My Buzz Lightyear term is 0. All of the terms way out at the end are 0. So if I add up all these, I will get one finite number. Yay! Okay, but that doesn't mean that this 100% converges. This means it could converge. It is a candidate for convergence, and then you would have to use another test, which we're slowly going to add on and build up till you have all the ones you need.